So now we will discuss about chemical reactions. That what are the chemical reactions which are shown by aldehydes and ketones. Okay. Chemical reactions of aldehydes and ketones that we are going to discuss. That what type of chemical reactions they undergo. See, first of all, we need to understand that what is the nature of the bond between the carbon and oxygen. Carbon-oxygen bond. This carbon-oxygen bond, it is polar in nature. Okay, this is polar. Why this is polar? Any bond is polar because of the difference in the electronegativity. Here, oxygen, that is more electronegative. The electronegativity of oxygen is around 3.5 and carbon electronegativity is around 2.2. So due to this electronegativity difference, there is the development of partial negative charge over the oxygen and partial positive charge develops on the carbon. Okay, and this makes this carbon oxygen bond polar because this electron, this is being attracted towards the oxygen because of high electronegativity of the oxygen. Okay, now as this carbon oxygen bond is polar and there is partial positive charge on the carbon, so aldehydes and ketones, they usually undergo nucleophilic addition reactions. Okay, they undergo which reaction? That is nucleophilic addition reactions. Now, what is a nucleophile? Nucleophile is that element or that substance which is having more electrons, which is rich in electrons, right? Now, this nucleophile, it attacks on the carbon. This carbon is having partial positive charge, okay? Partial positive charge. This nucleophile, because of higher number of electrons, okay, it attacks on this carbon atom. Because the negative one, that will search for electrophilicity. Electrophilicity means where there is shortage of electrons. Now, because this carbon is having partial positive charge, okay, and this nucleophile is having negative charge that is having excess of electrons, so it will attack at this carbon atom. Okay, that is why aldehydes and ketones, they undergo nucleophilic addition reactions. Why? Because of partial positive charge on the carbon developed due to the electronegativity difference and thus making the bond polar. Okay. Now we have understood that nucleophilic addition reactions are happening. Now we have to discuss that between aldehydes and between ketones and aldehydes, which is more reactive. So out of them, aldehydes are more reactive. Aldehydes are more reactive for nucleophilic addition reactions. Okay. Why aldehydes are more reactive? There are two reasons for that. The very first reason is electronic reasons, and second reason is steric reasons. Okay. What is this electronic reason? See, in case of ketones, what we have, that is RCO R dash, and in aldehydes, the formula is RC double bond O and H, right? Now we know this R group, it is having plus I effect, means it is electron donating in nature, right? This carbon, firstly, we know, we have discussed that this carbon is having partial positive charge because of the electronegativity difference between oxygen and carbon, right? Now this R group, it is having plus I effect, means it is pushing its electron towards the carbon, which means that electrophilicity, electron deficiency on the carbon in case of ketones is less. Why? Because there are two alkyl groups which are having plus I effect, they are present in the ketones. Okay, but in the aldehydes, only one R group is present. Only one R group is there, and another is hydrogen. Okay, now means that here electron deficiency is a higher. Why? Because one alkyl group is giving its plus I effect over there in the aldehydes, but in ketones, two alkyl groups are posing their plus I effect. That's why aldehydes, they are more reactive, that we have discussed from the electronic reasons. Now, in case of steric reasons, again, in ketones, again, the reason is RCO R dash, and aldehydes are RCOH. Okay. In ketones, these two bulky groups are present, which makes the attack of nucleophile difficult. Okay. Attack of nucleophile is difficult in case of ketones because of two bulky groups. Two bulky alkyl groups are present over there. Okay. That's why nucleophile is not able to attack properly. But in aldehydes, nucleophile attack is easy because a hydrogen don't involve in the steric hindrance. Okay. Hydrogen is not giving that much steric hindrance given by two alkyl groups in ketones. That's why from steric reasons also aldehydes are more reactive. Okay. So these are the two reasons why aldehydes are more reactive for than ketones for nucleophile addition reactions. And in this, we have understood that why aldehydes and ketones, they undergo nucleophilic addition reactions, right? Now, we will discuss an example of addition of a nucleophile, okay? We will discuss addition of HCN, that is hydrogen cyanide. Okay, this is an example that we are doing of nucleophilic addition. See, this HCN, it will disintegrate into Cn negative plus H positive, right? This is our nucleophile, electron rich. Now, C double bond O. This Cn negative, it will attack on the carbon, okay? When it will attack on the carbon, this carbon from sp2 to sp3 stage, it will go. Its hybridization will go from sp2 to sp3. Here it was sp2 hybridized, okay? And over here it is sp3 hybridized. This double bond, it will break towards the oxygen, okay? Now, in the presence of H positive, which will attack over here, it will result in the formation of OH and Cn. And this is called as cyanohydrin. Okay, so this is an example of nucleophilic addition reaction that you have to give whenever a question will be asked from the nucleophilic addition reactions. Okay.